Hello, welcome to the fifth unit, single variable calculus. In this video, we are going to see about Rolles theorem. So before going to see the statement of Rolles theorem, let us see some definitions related to the Rolles theorem. First one is continuity. Continuity at a point. The function f of x is said to be continuous at x equals to a if limit extends to a plus f of x is equals to limit extends to a minus f of x is equals to f of a. Next is continuity in the interval. So a function is said to be continuous in the interval, closed interval a comma b, if it is continuous at each and every point c belongs to the open interval a comma b. That is, limit extends to c f of x must be equals to f of c, and limit extends to a plus f of x equals to f of a, and limit extends to b minus f of x equals to f of b. Geometrically, if f of x is continuous in closed interval ab, then the graph of that function y equals to f of x is a continuous curve for all the points x in closed interval a comma b. That means there is no without any breaking points. Next, derivability at a point. The function f of x is derivable at x equals to a if limit extends to a plus f of x minus f of a by x minus a must be equals to limit extends to a minus f of x minus f of a by x minus a exists, and it is denoted by f dash of a. So coming to the derivability in the interval, a function is said to be derivable in the interval ab if f of x is derivable at every point c belongs to open interval ab. That is, limit extends to c minus f of x minus f of c by x minus c exists, and limit extends to a plus f of x minus f of a by x minus a, and limit extends to b minus f of x minus f of b by x minus b exists. Geometrically, if f of x is derivable in closed interval ab, then there exists a unique tangent to the curve at every point in the interval. So some note is there here. If f dash of x is greater than 0, then f of x is an increasing function as x increases. Similarly, if f dash of x is less than 0, then f of x is a decreasing function as x increases. And generally, e power x sin x cos x is continuous and derivable everywhere. Log x is continuous and derivable in closed interval 1 comma open interval 8. So every polynomial function is continuous and derivable everywhere. So if f of x and g of x are continuous functions, then f of x plus g of x, f of x minus g of x, f of x into g of x are also continuous, and f of x by g of x is continuous if g dash of x is not equals to 0. This property we have seen already in the intermediate. Now we are going to see about Rolles mean value theorem. What is this theorem statement is, if f of x is continuous in closed interval ab and derivable in open interval ab, and f of a equals to f of b, then there exists at least one point or value c belongs to open interval ab such that f dash of c equals to 0. So this is the statement of the Rolles theorem. But geometrically what it tells is, right? So geometrically what the Rolles mean value theorem states that there is at least one point c of the curve at which if you draw the tangent and the tangent is parallel to the x-axis, that means the slope of the tangent must be equals to 0. So geometrically this is, so this is the curve y equals to f of x, right? So according to the Rolles theorem, definitely there must exist a point on this curve in such a way that whenever this function f of x is continuous as well as derivable, then according to Rolles there must exist at least one point on this curve such that the slope at that point must be equals to 0. So here at this point, if you see, if you take a tangent, right, the tangent is parallel to x-axis, therefore its slope is 0. So that is the meaning of the Rolles theorem geometrically. Okay, now we'll see some problems on the Rolles theorem. So first one, verify Rolles theorem for f of x equals to x square minus x minus 6 by x minus 1 in the interval minus 2 comma 3. Clearly, if you look at this function is discontinuous at x equals to 1, because if you put x equals to 1, right? This is not defined. Therefore, the first point itself, f of x is discontinuous at x equals to 1. Therefore, Rolles theorem is not applicable for this. So, Rolles theorem is applicable only whenever it satisfies the first two properties. That is, it must be differentiable, it must be continuous, as well as it must be differentiable in the interval. So, here it is failed at x equals to 1. Therefore, Rolles theorem is not applicable. So coming to the second problem, verify Rolles theorem for f of x equals to x into x plus 3 into e power minus x by 2 in closed interval minus 3 comma 0. So this is the given function. So this function is clearly continuous in closed interval minus 3 comma 0 because there is no such type of point where the function is not defined. Okay, so everywhere it is defined. And if you calculate f dash of x for this using the product rule, so you will get this one. So 1 by 2 e power minus x by 2 into 6 plus x minus x square. So clearly the derivative exists for all x. So for all x in minus 3 comma 0, clearly the derivative exists. Therefore, the function is derivable. Next, if you look at the value of the function at the endpoints at minus 3 is 0. If you put here x equals to minus 3, clearly f of minus 3 is 0. If you put x equals to 0, f of 0 is 0. Therefore, it is satisfying all the three properties. Therefore, it is Rolles theorem is satisfied here. So, whenever it is satisfied, the conditions of Rolles theorem. So, according to Rolles, there must exist at least one value c belongs to the open interval minus 3 comma 0 such that f dash of c equals to 0. We already calculated f dash of x. Just replace x with c. So, you will get this one 1 by 2 e power minus c by 2 into 6 plus c minus c square equals to 0. So if you equate that one equals to 0, this exponential is never equals to 0. Therefore, in this interval, so definitely this must be equals to 0. So 6 plus c minus c square equals to 0. So if you factorize that, we will get the roots is 3 minus 2. So clearly minus 2 is belongs to this interval. Therefore, we require at least one value. So that is available here. Therefore, Rolles theorem is verified. Next, verify Rolles theorem for f of x is e power x into sin x minus cos x in this interval. So first check for the continuity. So clearly it is continuous as well as it is differentiable because e power x sin x cos x are everywhere continuous and differentiable. Therefore, this function is differentiable as well as continuous. And next, calculate the value of the function at the endpoints. So f of pi by 4, f of pi by 4, if you calculate, clearly it is 0. That means it is satisfying the conditions of the Rolles theorem. So according to Rolles, there must exist one value c belongs to the open interval such that f dash of c equals to 0. So we already calculated f dash of x here. So in that, if you replace x with c, we will get this one. So sin c equals to 0 after simplification. So c is n pi. So clearly c equals to, if you plug in n equals to 1 pi, pi is belongs to this interval, hence Rolles theorem is verified. Next, using Rolles mean value theorem, show that this polynomial has a 0, that means has a root between 0 and 1. So since this is a polynomial, it is always continuous and derivable. Then according to Rolles, as well as here, if you substitute the endpoints of this interval, clearly they are 1. So all the conditions of the Rolles theorem is satisfied. Therefore, there must exist at least one point c belongs to open interval 0 comma 1 such that g dash of 0 equals to 0. So if you substitute that 24, so if you calculate g dash of x, here it is 24x square minus 12x minus 2. So in that, if you substitute x equals to c, you will get this one. So from this c equals to 3 plus r minus root 21 by 2. So that value is 0.63 or minus 0.132. So clearly 0.63 belongs to this interval. Therefore, we are successful in finding one root which is in this. Therefore, it is has a 0. Clearly it is has a 0 means it is has a root between 0 and 1. Okay. So thanks for watching. I am Srikanth Reddy. I will see you in the next video.